Hello and welcome back. This is episode 7, using a law to help remove double iteration. My name is Reed Evans, and you can find me on Twitter at ReedNEvans. So, laws aren't always a good thing, but in this case, one of the things that we're going to do is to show how we can refactor code and be certain that it will work as we expect because there's a law backing this. So here's the setup. So I have an array here. This is taken from scrub data from basically a real thing that I'm working on. We've got a list of apps that we have, and each of those apps can have child apps or child screens that we actually want to have for it. And what I really want to do, I'm using React and React Router. And what we want to do is that for each of these children that we have here, and of course we have children here under this app as well, we want to make sure that we have a route and that we can render, in this case, a panel manager, which is a custom component. So we want to be able to pass that through. So we want to be able to take this sort of data and for each child, render out a panel route. We've got a few helper functions here, but this is basically what I came up with at first, is this panel routes. So it's a composition of, remember we read right to left with this because we're using compose. I've got a video on pipe compose that you could also look at if you're not sure why that is. You can definitely check out my other videos, which I'll link. So in this case, we're going to do a chain, and we're going to get the children prop of the result of that chain. So first off, I'll take a brief segue into chain. So why chain rather than map? Well, as we see right here, this is an array. Apps is an array, and this array has arrays. So if we were to map over apps, what we would get is, if we were to map over apps and get the children properties from that, we would have an array of 2 arrays, because we would get back the value of the children property for each of those, which there's 2 of them, and then we would have an additional array. And basically what chain does is it's just going to flatten that. So now we get an array of just the children. So we'll have essentially this array appended with this array. Basically those 2 arrays appended together. And that's what chain will give us. And then after that, what I needed to do was to get the panel, because if you see here, the reason that we need to get the panel is because in this case I have a name and a link, which is great. This panel route function needs a link, an object with a property of a link, but it also needs a panel. And so this get panel helper will basically go get the panel that we need from our in-memory list of panels, and basically just tie it together. And so then once we've gotten that panel from our map, then we can map it. Then we can map over the panel route. This is great. That's what we would expect. So if we look back at our initial structure here, I end up getting 5 routes rather: child, child 2, child, child 2, child 3 for other app, and then the links all match and everything's good. The problem here though is that this isn't very efficient. We're calling map here, and we're also calling map here, which that means we're looping through the exact same list twice, or the exact same array twice. And in this case, this is where we can take advantage of a law, and it just so happens to be known as a functor law. But basically what it says is that if we compose a map of F and a map of G, it must be equivalent to mapping the composition of F and G. If you look right here, if we substitute panel route and get panel for F and G, then it matches up exactly with the scenario that we have right here. So what we can do is we can create another little function, child to panel route, and basically compose panel route and get panel, which is basically F and G from this exact same functor law. And that then allows us to rewrite panel routes to where we just map over the composition of the 2 functions. So now we've only mapped over that once, we've only iterated through it once, and we still get what we would expect. So just to show the difference between the 2, and we have our original one here, where we've mapped panel route, we map get panel, and then we map panel route, And in this case, we've composed those two out into its own function, and now we can map over it once. So now we just have single iteration. And because of this law that exists, we know that we're safe in what we're doing, and that the refactor will work as we expect. This has been episode 7, using a law to help remove double iteration. I've been Reed Evans. Thank you so much for joining. Hope to see you tomorrow.